Okay, this is extended response questions numbers 23 to 28. Use the graph to answer the following. Okay, so first question, what is the vertex of the parabola? So we know the vertex is this minimum point. So if I look at my graph, it is 3, -4. Make sure you express that as an ordered pair. Is the vertex a max or a min? Since it's at the bottom, the parabola is opening up, the vertex is at the bottom, so it's the lowest point, so it's a minimum. What is the axis of symmetry? So the axis of symmetry is this vertical line that I could draw straight through the vertex, and it passes through the x-axis at 3, and that's also the x-coordinate, so it's x equals 3. What are the zeros? The zeros are where you pass through the x-axis, where the parabola passes through the x-axis. So it looks like it's passing through at 5 and at 1. So my zeros are when I'll just write 1 and 5. Okay, so that's it for that one. 24, same idea. Use the graph to answer the following. So this time the vertex is at the top because our graph is opening down. So it looks like it's 1, 8. It's at the top of my graph, so it's a maximum. The axis of symmetry, again, straight through the vertex, passing through the x-axis at 1. And the zeros now would be 3 and -1. And those are not written as an ordered pair because they're not together. If you want it as an ordered pair, it would be -1, 0, and this one could be expressed as 3, 0. I guess same over here. I should go back and do that here as well. So 1, 0, and 5, 0. Okay, 25. The formula h equals -16t squared plus vt models the height of a ball, where h is the height in feet, t is the time in seconds, and v is the initial velocity in feet per second. If the ball is kicked with an initial velocity of 32 feet per second, so I'm going to underline that so I remember that, will the ball ever reach a height of 18 feet? Justify your answer using complete sentences. Okay, so our velocity is 32. So I'm going to rewrite this equation with 32 in for v. So h equals -16t squared plus 32t. So a couple different ways I can do this. I can use my calculator. I can find the vertex by hand, so I'll just kind of talk you through both. Okay, so remember the vertex comes from the opposite of b over 2a. So if I do the opposite of b, my b is 32, so -32 over 2 times -16 is going to be -32 over -32, which is 1. And then if I plug 1 back in to my equation, -16 times 1 squared plus 32 times 1, I'm going to get -16 plus 32, which is 16. So my vertex is 1, 16. The question is, will the ball ever reach a height of 18 feet? So basically, if this is my vertex and this is negative, so now let's use our calculator for the moment. What should happen is my graph should be upside down, right, because of the negative, and the highest point it gets to is 1/16. So now we can double check that on our calculator. Glare. Maybe right there. So y equals, clear, -16, I'm going to use x instead of t, same thing, x squared plus 32x. Now, we did by hand that my vertex is 1/16, so I'm going to go back here and change my window and make my y max higher. I'm going to go up to 20 and go by 2's, because otherwise if I only went up to 10, I'm not going to see the top of my parabola. So hit graph, and remember these are by 2's, so when I count, the x's are still by 1, so that's 1, and then when I go 2, 4, 6, 8, 10, 12, 14, 16, that's what we said. Okay, so I can tell that that's the picture. So the question is, will the ball ever reach a height of 18? Well, 18's up here, and the highest the ball is getting is 16 because that's its max height. That's what vertex means. So no, the ball will not get to 18 feet. Okay, so our answer, justify your answer using complete sentences, would be no, the ball will never reach a height of 18 feet because its maximum height is 16 feet. And I know that because of the y-coordinate of the vertex. Okay, 26. The formula h equals negative 16t squared plus vt models the height of a model rocket, where h is the height in feet, t is the time in seconds, and v is the initial vertical velocity in feet per second. If the model rocket is fired at an initial vertical velocity of 80 meters per second, so I'm going to underline that, will the rocket ever reach a height of 92 meters? Justify your answers using complete sentences. Okay, so again, this time my v is 80 because initial vertical velocity of 80. So h equals negative 16t squared plus 80t. Okay, so I'm going to do my vertex by hand again. And again, I can punch this in on the calculator, but I'm going to just practice doing it the way we learned. So opposite of b over 2a is negative 80 divided by negative 32. If you type that into your calculator, negative 80 divided by negative 32, you get 2.5. So I know the x part of my vertex is 2.5. The y part, again, I'm going to show you by hand, and then we'll look at it on the calculator. So 2.5 squared plus 80 times 2.5. If I type this in, negative 16 times 2.5 squared plus 80 times 2.5, you should get 100. So this means my vertex is 2.5, 100. Doing it by hand also helps because then I know what to set my window at instead of just playing with it. Okay, so I'm going to type in my equation. Oh, sorry, a glare. There we go. Negative 16x squared plus 80x. Again, my vertex is 2.5 comma 100, I think. So my x's will be okay, but my y's I need to go much bigger. So I need to go, so if the top's going to be 100, how about we go 110, and maybe our scale, we're going to go by tens, so that I'm counting by tens this time up and down. Okay, here's my graph. Now remember, I'm at, my x's are still 1, so 1, 2, remember it's 2.5, and these are by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So yep, it looks like it's good. I'm up at 100. Okay, so that confirms what I did by hand. So now the question is, will the model rocket reach a height of 92 meters? So because my maximum height is 100 meters, yes, it will get to 92 meters. So yes, the rocket will reach a height of 92 meters because its maximum height is 100 meters. All right, 27. A population of 40 ants doubles every 2 years. Okay, so we talked about if something is consistently multiplying, then that means it's an exponential function. And oh, here, write this exponential function representing this information. Okay, so I'm going to underline what I start with. I start with 40 ants. I'm going to circle what it does. It doubles. And I'm going to box how often that happens. So that's every 2 years. So I'm writing my equation as y equals a times b to the x. Remember, a represents the starting point, and b represents the pattern or what's happening to that starting. So y equals a would be 40, because that's how many I'm starting with, times, so it's doubling, so b is 2 to the x power. And part b, calculate the ant population in 24 years. So this is where I use my box of 2 years. So my x is going to be every 24 years, I want to know how long, how many times it doubles if it doubles every 2 years. So I'm going to divide that by 2. Notice that my units are the same, so I don't have to change anything. 24 divided by 2 is 12, so it's going to double 12 times in 24 years. So then I take that value for x, I go to my equation, and I type in y equals 40 times 2 to the 12th on my calculator. When you do that, you should get 163,840, and this is ants. All right, same idea on 28. A population of 100 bees triples every 3 years. Write the exponential function representing this information. So y equals, I'm starting with 100 bees. They triple, so times 3 to the x. I want to know the population in 12 years, so first I have to find out how many times it triples if it's every 3 years. So x is going to be 12 divided by 3, which is 4. It's going to triple 4 times. So y equals 100 times 3 to the 4th power. And that would give me 8,100 bees. And that is the end of this page.